Okay, in this lesson we are going to practice calculating a sample mean and sample standard deviation for two different sets of ages here. We're going to be looking at four Menace soccer players whose ages are 22, 22, 26, and 24, and we're going to calculate the sample mean as well as the sample standard deviation. Okay, so as far as the sample mean, we're going to be adding each of those values to get a total of 94 and dividing by the number of values that we have, which is 4. That is going to give us an average of 23.5. So the average of these ages is 23.5 years of age. Now we're going to use this formula for sample standard deviation. And I want to make sure that you have plenty of practice with this because this is something you will need to show proficiency on an exam. So just heads up, you will need to do this on an exam. So I'm writing down my square root sign. Now I need to calculate the differences of each of these data values, how far they vary from the actual mean for this sample. So my first data value is 22 minus 23.5. Whatever that comes out to be, I'm going to square it. My second data value is also 22. So 22 minus 23.5 squared again. My third data value, I'm going to look at the difference between 26 and the 23.5, and my last data value is the 24 minus 23.5. So each of those differences we're going to square. So I've just recorded that all in there. Now notice I'm going to be dividing by 3 because our formula is n minus 1. N is the number of data values we have. We have 4 data values, so we're going to be dividing by 3. Okay, so my next step is I find each of those differences. 22 minus 23.5 is negative 1.5. I need to square that. Same thing for the next one. 26 minus 23.5 is 2.5. I'm going to square that. And our last one's difference is squared as well. Okay, so my next step is to do each of those differences and square them. So notice that negative 1.5 squared becomes positive 2.25. So all of these squared differences will be positive. So when we add up that numerator there, we come up with 11. So I'm going to be looking at the square root of 11 divided by 3. I would suggest that you divide 11 divided by 3 is 3.6. So your last step is to square root that. Many times students forget to square root that. So we come up with a standard deviation of 1.9. So all this means is that typically the ages of our soccer players, the difference from each data value differs from the mean by not quite 2 years. And when we look at that, yeah, that kind of makes sense. I'm hoping that you will pause the video right now and go ahead and try the second example on your own. On this one, we're finding the mean and the standard deviation for ages of a sample of 4 fans in the stands. So you're going to be doing the same thing again. Okay, so hopefully you've done that and you've come back and you can compare your work here. So again, finding the sample mean, we're going to add each of those data values and divide by 4, and we come up with an average age of 24.5. So that average age is pretty similar to the average age of our players. But we're going to hopefully use that formula for the sample standard deviation, and we plug in and find all of these differences. Many times students forget that they are doing these differences one by one. Then they are squaring those differences before they sum them. So again, your last stage here underneath for the numerator is to collect all those values. We end up with 601 divided by 3, so we would be square rooting 200.33, which comes out with a standard deviation, a sample standard deviation of 14.2. So we're looking at that. The typical age of the fans typically is a difference of 14 years from the mean of 24.5. Now these two samples are really small, and you can just glance at that and see that, yeah, that first data set is pretty tight. They're pretty close, so a typical difference of almost 2 years from the average is not that big of a deal. The second sample is much more spread out, and so the typical age differing by 14 years seems about right. But if you had two really large data sets, several hundred data sets, this would become very cumbersome to do by hand. So hopefully you have watched the video and learned how to do this with StatCrunch. In fact, I could probably pull that up and show you that right here. I've entered the ages of our players and the ages of our fans in StatCrunch. So if you remember, you go to Stats, Summary Stats, and then over to Columns. So I'm going to get out of that again and show you Stats, down to Summary Stats, and over to Columns. I'm only going to be using the first two columns, the ages of my players, and if I want to do both of these at the same time, I'm going to click on that first one, and then I need to also hold down the Control key, and I will click on the ages of the fans. I'm going to pull that up right here, and I go down to Compute, and the StatCrunch is wonderful. It does it all for us. I'm looking at the ages of the players. 23.5 is the mean. The ages of the fans, mean is 24.5. The only two columns we're looking at in this example is the mean and the standard deviation, which matches up with what we had in our example that we did by hand. But you can check your work with StatCrunch. So I think you can see where this would be really nice to have this for large data sets. Okay, I also want to go on and talk about, I've already mentioned about the difference, the average of the average age of the ages is similar, but we can see that there's a lot more spread among the fans than there is with the players. That's why we call the mean, calculating the mean is a measure of center, and calculating a standard deviation is a measure of variation, because it shows you how much variance there is. Okay, variance is another term and another thing that can be calculated when you're dealing with data sets. And basically all that sample variance is the square of the sample standard deviation. All that the population variance is the square of the population standard deviation. So typically your population is much, much, much larger than a sample of that population, and very often it's very cumbersome to calculate the mean and the standard deviation. So that's why we take a sample and we calculate the mean and the standard deviation, because we know that the sample variance is an unbiased estimator of the population variance, which means that this sample standard deviation squared, which is what our sample variance is, it tends to target the population variance. So we can do a small sample, as long as it's a good sample that is typical of the population, to help us make a projection about the true population variance and true population standard deviation. So that's our goal here. That's why we do this. So I've just kind of abbreviated the different measures of variation, our sample standard deviation and variance, as well as our population standard deviation and variance, and that notation that goes with that. So you need to get really comfortable with the notation to recognize that S and S squared represent our sample standard deviation and variance, sigma and sigma squared represent the population standard deviation and population variance. Okay, back to our sample about the Menace soccer player and the Menace fans. Finding the variance for each of these, we would take that standard deviation squared. In the case of the soccer players, we end up with 3.6. For the fans, remember, they differed by, typical fan varies by 14.2 years, but when we square that, we end up with 202. So that's quite a large variance. So I'm hoping that you're recognizing that our standard deviation is in the same units of measure. We're talking years for our standard deviation, but our variance, once we square that, we get this wacky number, and it's really hard to wrap our head around what that meaning might be. Toward the end of our course, we're going to be doing a lot more hypothesis testing, and we'll get a better handle on what our variance, how the variance is used. But are these sample or population variance? Both of these, because we were squaring a sample standard deviation, both of these are sample variances.